The next group of transformations we're going to be talking about are dilations. Dilations are kind of tricky to tell apart. It's hard to tell apart the x dilations and the y dilations. So I'm going to use this example. This is not one of our parent functions. You can see it's just a semicircle, and I deliberately hid the equation because the equation of the original function is not important. What's important is what happens when I apply a transformation to that equation. So let's start by applying a transformation outside the function. Now when we do dilations, we're multiplying instead of adding. So instead of adding 2, I want to multiply by 2. So 2 times. So notice what happens to my semicircle. The 2 points on the x-axis don't move, but the peak of the graph stretches up twice as tall as it was before. It was at 0, 4, now it's at 0, 8. This point here was about negative 2, 3.5, and now it's at negative 2, 7. So every y value is twice as far from the x-axis as it was before. If I multiplied it by 1/2 instead, I'll just put 0.5, notice all of the y values now are half as tall as they were before. So I could pick any x value, go to the y value, and notice the corresponding y value of the blue function is half as tall as it was before. Now let's look and see what happens when we do the same things inside the function. So what if I multiply by 2 inside the function? This is going to affect the x direction rather than the y direction. So think kind of in your mind what you think is going to happen if I multiply by 2 inside the function. Were you thinking that the graph would get twice as wide? No, it gets half as wide. And this is because x has to be half as big as it was before in order to get the same y value. If I multiply x by 2, then I'm using smaller x values to get the same y value. So for example, I had the point 4, 0. Now if I put 2 in for x, I say 2 times 2 is 4, and I get 0 for y. So it has the effect of making the graph half as wide or half as close to the y-axis. All of my x values are half as big for each of the corresponding y values. So imagine you can guess that if I multiply by 0.5, it's going to be twice as wide. Notice that the y-intercept does not change, because if x is 0, multiplying 0 by any number doesn't change it, so we get the same y value. But every other x, if you multiply it by 0.5, x would have to be twice as big in order to get the same y value. So for example, I have the point negative 3.52. Negative 3.52. Now, in order for y to be 2, x would have to be 7. It would have to be twice as big because I'm multiplying it by 1/2. So dilations are a little tricky as far as stretching, because you'll see when we do the example in the notes, sometimes it's hard to see if something is getting taller, or if it's getting thinner, or if it's getting wider, or if it's getting shorter. So you do have to remember that focus on x coordinates changing when you make a change inside the function, focus on y coordinates changing when you make a change outside the function, and the ones inside the function will cause the x to go in the opposite direction as what you do when you do the y outside the function. Okay, so now go ahead and do the video for your notes on the top of page 8.